In a daring announcement, scientists have claimed to have discovered a new planet, unlike anything known before. NASA, renowned for its groundbreaking findings, has revealed that this planet is fascinating not only because of its size and location, but also because it displays light that appears to be artificial. This discovery raises profound questions about the universe and whether it might indicate the existence of life on other planets. As we explore NASA's incredible findings, we edge closer to uncovering secrets that could transform our understanding of the cosmos. In 2007, NASA launched the Dawn spacecraft on a mission to study some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. The spacecraft sent back detailed images and data revealing Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn began the second and arguably most exciting phase of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and travel toward Ceres, something traditional chemical propulsion would not have allowed. These engines provided a gentle yet persistent thrust, enabling the spacecraft to cover vast distances and establish a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Pi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006 with a diameter of approximately 950 kilometers. Ceres is the most massive body in the asteroid belt and one of the most fascinating due to its unique characteristics. Scientists eagerly anticipated the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, especially within a large crater known as Occator. These bright spots sparked immediate interest and speculation within the scientific community. Before Dawn's mission, the best images of Ceres were blurry, low-resolution ones taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of close-up observations held the potential for groundbreaking discoveries. The Dawn mission aimed to enhance our understanding of the solar system's formation and the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, were thought to consist of highly reflective material, possibly salts left behind by sublimated water. This discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt liquid water or brine instead of molten rock. The enigmatic bright spots raised questions about their origins and what they revealed about the nature of Ceres. Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands out from other bodies in the asteroid belt due to its size, mass composition, and potential to contain water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, hinting at secrets about the early solar system. After 2 years of transit, the Dawn spacecraft began its approach to Ceres in early 2015, marking a significant milestone as it prepared to deliver the first close-up views of the asteroid belt's largest object. As Dawn drew nearer, images of Ceres became increasingly detailed, revealing a world previously cloaked in mystery. The initial images showed a cratered surface, indicative of a long history of impacts. What captivated scientists and space enthusiasts alike were the mysterious bright spots scattered across the dark, rocky terrain. As image resolution improved, theories about the nature of these bright spots began to take shape. Were they patches of ice reflecting sunlight, or could they be something even More exotic speculation range from mineral deposits to signs of cryovolcanic activity. Closer inspection revealed that the brightest spots were not single entities but clusters of distinct areas. The most widely accepted hypothesis suggested that these were deposits of salt left by the sublimation of water. This finding implied that Ceres either had or still has geological activity capable of bringing water or brine to the surface where it quickly evaporates, leaving bright, reflective residues. These revelations challenge prior assumptions about Ceres, painting a picture of a more dynamic and complex world than previously imagined. The possibility of subsurface groundwater or brine pockets has profound implications for our understanding of potential life in the solar system. Ceres is often described as an icy world with a porous rocky surface, distinguishing it from the rocky, metallic asteroids that dominate the belt. Its unique composition includes a mixture of water, ice, and hydrated minerals such as clays and carbonates, which give it a less dense structure compared to its rocky neighbors. This composition suggests that Ceres contains significant amounts of water, with its surface layer being rocky but porous and containing volatiles like ice. In many ways, Ceres is more akin to a comet than a traditional asteroid. The dwarf planet is believed to have a distinct internal structure composed of a mud mantle and a core rich in water ice, which accounts for approximately 50% of Ceres' total volume. The mantle is likely a mixture of rock and brine surrounding a core of denser materials such as silicates. The presence of substantial water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was heated by radioactive decay early in its history. This internal structure distinguishes Ceres from its asteroid belt neighbors and raises intriguing questions about its geological evolution and the role of water in its development. Adding to its intrigue, the discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder region of the solar system and later migrated inward. Ammonia can lower the freezing point of water, potentially supporting the existence of surface brines. These insights into the composition and history of Ceres not only deepen our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes that govern icy bodies throughout the solar system. Cryovolcanism, a relatively rare geological process, has captured scientists' attention on Ceres. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes or ice volcanoes expel materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extreme cold environments where cryovolcanism occurs. On Ceres, cryovolcanoes allow water laced with dissolved salts to reach the surface. When this brine encounters the vacuum of space, it rapidly sublimates, transitioning directly from a liquid or solid state to gas. This process leaves behind highly reflective deposits of salt. The most famous of these bright spots is located within Occator Crater, known as Facula. This area has garnered significant attention due to its high reflectivity and the periodic hazes observed by the Dawn spacecraft. These hazes are believed to result from water sublimation, suggesting that cryovolcanic ACI may still be occurring or have occurred relatively recently on Ceres. In addition to Ceres, Falla Ceres hosts numerous other bright spots, each with unique characteristics. These spots are scattered across the surface, indicating that cryovolcanism may be widespread on the dwarf planet. The presence of these bright spots underscores the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically inactive world. As the Dawn spacecraft captured more detailed images. A wide variety of surface features began to emerge, each telling a story of Ceres. Rich history from crater terrains to the bright reflective deposits of salt. Ceres has proven to be a world of surprising complexity and mystery, offering new perspectives on the evolution of icy bodies in the solar system as researchers continue to analyze data from the Dawn spacecraft. The discoveries surrounding Ceres have only grown more compelling. The dwarf planet's unique characteristics, including its composition, geological features, and potential for water, position it as a key object of study in the quest to understand the solar system's history and the conditions necessary for life. The enigmatic bright spots on Ceres, particularly those in Occator Crater, have been at the center of scientific discussions. These reflective areas not only suggest ongoing geological processes but also hint to the presence of subsurface reservoirs of brine that may still be active. Occator Crater, the most studied feature on Ceres, measures about 92 kilometers in diameter and is home to several bright spots, with Callia facula being the most prominent. This cluster of highly reflective material appears to consist of sodium carbonate, a type of salt that forms when brine is brought to the surface and the water evaporates. The presence of this salt points to the likelihood of liquid water beneath the surface, a discovery that has profound implications for astrobiology. While no direct evidence of life has been found, the possibility of subsurface water, combined with the organic compounds detected on Ceres, raises questions about whether the dwarf planet could harbor conditions suitable for microbial life. Adding to the intrigue is the presence of haze-like phenomena observed within Occator Crater. These transient mists are believed to be caused by sublimating water vapor, which could indicate recent or even ongoing cryovolcanic activity. Such activity would imply that Ceres remains geologically active,